Alright, hell yeah. Now this is a fun one, and no one solves it the way I do, because we got to use logarithms, and we got to use logarithms twice. So let's just frickin' A, let's get to it. So hey, look at that. That's the whole exponent, that's the whole exponent. So we got to bring it down to the party. Let's do it. Let's just bring it down to the party and figure out what we want to do later. Okay, now it's later, and we want to take the log of 5. You know what I mean? I want to do log base 10, but even this could indicate that it's natural log 2. It don't matter. You just have to indicate what you want it to be. Oh, okay. And then we're going to do over here. So we're going to take this whole thing down. 5 to the x minus 3. Log base 3. Okay, perfect. You know what I mean? So now, should we do anything? Should we do anything with this? No. Not yet. But now we're going to... well, there is two ways. One can make your life a little bit simpler, but let's say you're not going to do that. You're just going to, hey, I just want to plug and chug and then work my way through this. We do have a product of two things, so get that. You got one thing here, one thing there. But I will mention, this one has an x in it, this one has an x in it. But guess what? This is just a constant, baby. You know what I mean? That's just a constant, so keep that in mind. But anyway, all right, so let's just chug it out again. So we're going to take, because it's a product, we're going to take a log. We're going to take the log of this plus the log of this. And then the same thing over here. Okay, let's just do it. X minus 5, we brought it down. Log base 10, I'd use base 10. Log base 10 of 3. Perfect. And now we're going to add it to log. Holy Toledo. Now, does this work? Hell yeah. Hell yeah. This is just a small number, and now it's just going to be a really small number. You know what I mean? But, okay, just like this is a small number, this is a bigger number. Whoa, this is a really big number. Okay, same thing. This is a, I think you get it. I think you get it. All right, so this is going to be equal to x minus 3 log base 10 of 5. Plus, because we've got a product, log of this constant, which is just log of 3. Now, if you got confused, even like right here, well, let's just do it on the side. Let's say you do call this, I'm just going to call this variable r, because we're going to use a, b, c, d for some of these. And this is just going to be variable s. So this right here is going to be r times 3x minus 5. Is equal to s times 5. Oh, damn it. That's kind of confusing on the 5. S times 5 to the x minus 3. Now let's take logs of both sides. So we're going to get log base 10 of r plus x minus 5 in parentheses. Log base 10 of 3 is equal to log base 10 of s plus x minus 3 log base 10 of 5. See how we only, you know, because right here you have, you know, you got to do the log. You see the log 4 times. But here it's like 1, 2, 3, 4, 5, 6 because we did it twice here. And it's just a lot of logs. Okay, so right now is where, now I will do that. I'm just going to go through because this is tied up. So here's your x's. This is just a constant, baby. And then this is your x. So this is tied up with an x. And this is just a constant. So our constants, let's just go A, B for our constants and put them into our calculator. And this is going to be C, D. You do you. You do you. And I'll just do that right now. So we got log of 5 is A. Store that as alpha A. Log of 3. Store that as alpha C. Log... Whoa, not natural log. Log 3 of alpha is... Oh, I didn't even store it. Okay. Store is alpha B. And then log base 5. A lot of places in math just to make errors. So I think we got it. A, B, C, D. A little double checky. And we're good to go. Okay, so now you can just do this. Instantly, it just becomes a normal... you know, run-of-the-mill equation. X minus 5 times C is plus A. Oh, simple. Is equal to X minus 3 times B. Geez. See. I should have just went A, B, C, D, but I like it because the A and B values are constant. C and D's are tied up with the X. They're a little bit different. Okay, plus B. Yeah, not as clean because I made a little, little scribbly there. Okay, so now this is just gonna be X to the C minus 5 times C plus A is equal to X to the D minus 3 times D plus B. Cool. So now we have our X terms, and then everything else is just, all this stuff is just a friggin' constant. You know what I mean? Right now, like literally, we used A, B, C, D. You could say this value is just E. This value is just F. I mean, if we did that, if you put this into your calculator, negative 5C plus A, you're literally getting X to the C minus E is equal to X to the D minus F. You know what I mean? How simple is this to solve? But we'll keep it like this. We'll keep it like this. And then so we're going to go X to the C minus X to the D. So that's on this side. We're going to keep the constants over here. So it looks like we got a B. We're going to subtract an A. And then we're going to add a 5C. And then we're going to subtract a 3D. I just wanted to get it just nice and tidy. Okay, and then even this is just X is equal to C minus D, and so we're just going to divide that. C minus D, and then scribbly, this is equal to X. Hope you saw that. And then booyah, let's throw it into our calculator. Now, I could have made errors, that's for sure. Plus 5C minus 3D, still can make some errors. And I don't even have the answer to this one. But there you go. X is equal to negative 0.5538. And I better pause the video right now because I need to check where I got this from and make sure that's the right answer. All right, catch you on the flip side. All right, holy Toledo. No, I did not check the right answer. No, I did not check to see if this was the right answer because I was just like, holy, if I can't do math, so we're just going to plug this in as X and we're just going to test it out. So we got 5 to the 3 to the X minus 5, and then that's 1 almost. And then this is 3 to the 5 to the X minus 3, and that's 1, basically. I don't know why it's not exactly 1. But it's just maybe rounding errors. But anyway, cool. And let's see why that's the... I got to catch on the flip side. All right, hell yeah. Now this is the part where I force myself to learn something about these numbers. You know what I mean? So if we just have the equation y is equal to 5 to the 3 to the x minus 5, we need to learn something about it. So sometimes I use the negative 1, 0, 1 approach, and I would throw in 10 and infinity, maybe negative 10, negative infinity. Because sometimes, if it's easy to throw in, let's just throw in 10. I think that's the simplest one to do. Since we're dealing with exponents, it's really easy to see 5 to the 3 to, we throw in 10, and we get negative 5. I think that's the most interesting thing about this. Let's say it was 5 to the 3 to the 10. Well, then this would just be a hella big number. But it's not, so this is going to be a small number. And I already looked at it because I cheated. I usually don't like to cheat like that because I want to learn something from square one. But even just right now, 5 to the 3 to the negative 5, that's only 1, which is kind of interesting. So we threw in negative 5, and we basically got 1. Now let's just keep doing that. 5 to the 3 to the negative... 5 to the 3 to the negative 100. And that is 1. Oh, so that is interesting. I actually got to throw this into my calculator. 5 to the 3 to the x minus 5. 5 to the 3 to the x minus 5. So we're gonna graph that. And we're gonna, that's why. I didn't realize, yeah. So this thing, so I'm cheating, but it's just interesting. It's basically 1, it's really close to 1 for all the way to, even throw in 0. You throw in 0, which is 5 to the 3 to the negative 5. And now can we even now why is this? Is that because this is a small number? And so let's just do 3 to the negative 5. Which is, sometimes I like to do this. This is 3 to the negative 5 over 1. Because this is kind of, if it was 3 to the negative 2, that would be equal 1 over 3 squared. And if it's negative 5 over 2, we would have to, this would be 1 over 3 to the fifths, and then we got to square root it. But it doesn't have a bottom component, but that's just what it, 3 to the negative. So the negative just means the 3 goes downstairs, got it. And then the 5 means we're doing this by 5. Okay, so in this case, we're getting 3 to the 5, so we're turning this into a pretty small number. And if it's 1 over 10, it's going to be 0.1. If it's 1 over 100, it's going to be 0.01. I always like to do this anytime I'm dividing by a big number. 1 over 1,000, because this truly kind of shows you what logarithms and exponents do. Because 1 divided by something is more like a log than, I don't even know what the hell I'm saying. But anyway, so this is 3 to the 5. I don't even know how to do that, but it's 3 times 3 is 9. 3 to the 4 is 81 times 3. Oh, okay, so let's just say this was 100. You know, it's like 275. It's close to 300. And well, let's just say it's 1 over 300. That's the other thing I like to do. Let's just say this is 1 over 100. It's 0.01. And let's just say this is 1 over 1,000. It's 0.001. Okay, so this number is right in between. So it's like 0.00. You know what I mean? Is it 3? Is it 6? Who knows? You know what I mean? And who cares really? But I think it's like, let's just say it's 0.003. Now sometimes I like to do this. 1 divided by 300 just to check. Yeah, and it's repeat. It's on repeat. But this is the fastest way to guesstimate. That's kind of what my style of math is just like, yeah. You're not going to learn until you actually kind of like understand, especially the halfway points. You know what I mean? The numbers, like guessing, well, I don't even know what's going on no more. Oh, yeah, we did this. We found that this is kind of just like 1,000. Like it's like 1 over 1,000. Okay, 1 over 1,000. And what's 5 to the 1 over 1,000? That's the interesting thing. Because what's 5 to the 0? If I didn't do this, the light bulb wouldn't have gone on right now and realizing that, oh, 5 to the 0 is 1. So anything that's 5 to the approaching 0, if this is literally approaching 0 from whatever direction, it's gonna approach 1. So that's why we do have this approach on 1. And even when x is 0, right here, we're so damn close to 1 because we're taking 5 to the 1,000ths. Now in my book, 1,000ths, because I do 1,000. This paper isn't even 1,000. You get 1,000 sheets of paper. It's like 4 inches thick. You know what I mean? So this paper is literally, well, I mean, it could be a 3/thousandths of an inch. Yeah, so that's what we're talking about. Anyway, so it's really close to 0. You know what I mean? If you say, oh, can I just take off 1,000th of an inch? You'd be like, no, just leave it. Who cares? Because you just take off 0. So that's why 5 to the 0 is 1. That's why this approach is 1. Now, we already saw the graph, and I could show it to you. You probably can't see it very well from here. Oh, and I just deleted it anyway. But yeah, it doesn't get steep. You know, even if we throw in x is 10. We're running out of light. But oh, okay. So yeah, 5 to the 3 to the x minus 5 to the 3 to the x minus 5. Graph it, and then we'll just trace it out. So that's the best thing. So anyway, so even when x is 2, this thing's still close to, oh yeah, because x is 2. Until x gets 5, this becomes 3 to the 0. So then this becomes 5 to the 1. Oh, and that's the other one that we just found out. If this is 3 to the 0, that becomes 1. And then you got 5 to the 1, which is 5. So when x is equal to 5, this thing's equal to 5. So let's go trace value 5. Booyah, we got 5. And then after that, this thing's hitting infinity hardcore. And then the only other thing was this one. It still approaches 1, but they do cross paths. Like this is on the inside, but then at some point it crosses. And where does it cross? Well, it actually crosses right there, and we already solved for that, and that was rounding out the video, which was it crossed at -0.5, so they cross right here at -0.5. But that's it. This stuff is the juice that that people don't tell you. So we want to do more of that. We'll get better at it. I'm going to call this one a video. Thanks for joining me, and guess what? That's a video.